Okay guys, so now we're on number 15 and it's asking find the adjoint of the following matrix. Okay, so what is an adjoint? An adjoint is actually the matrix, it's the transpose of the cofactors of a matrix. So transpose of cofactors. So the cofactors for the following we can find, let's just say, let's start with C11, right? C11 is equal to, 1 times uh, 1, 0, negative 1, 1. C12, that's this one right here. Well, that's just equal to, cross out that column, cross out that row. That's gonna be 3, 0, 0, 1, right? And then C13 is equal to, what do we have here? C13 is, this is a negative. 2, we have a 2 here. 2 times 3, 1, 0, negative 1. I'm just gonna solve these real quick. We're going to the next row. Next row after. So 1. This is 1. C11 is just 1. C12 is just 3. Nah, negative 3. Right? If you see a negative 3 somewhere, first of all, you could already start limiting the possibilities. You don't see a negative 3 here, here, here. I would pick D as the answer, just to make sure. What's C13? C13 is 3, negative 3, so negative 6, I would say. Negative 3 times 2, it's negative 6. Okay, so yeah, so we have that right here. So 3, 1, negative 6, C11, C2, 2. Okay, just give me a second. So I just wanted to correct a mistake I made. I made a mistake here where I actually multiplied by 2, where I'm not actually supposed to multiply by 2, I'm actually just supposed to multiply by a negative, right? And this would just be, well, the answer here, well, this is positive actually. So we have, in my previous video I discussed where when we add up the row plus the column it's in, tells us, and if it's even or odd, tells us the sign. Well, C11 is in row 1, column 1, which gives us 2, and that's even. That's why the sign here is positive. C12 is in row 1, column 2, which when you add those up equals 3. That's why C12 is negative. Right? We have C13. C13 is in column 3, row 1, which is 4, and that's positive right here. So this should be the answer. C13 is actually negative 3. If we continue on, we get C21, and C21 is what do we have here? C21. So column 2, row, or we can do row 2, column 1. What do we have here? We have, just cross that out. We have negative 1, 2, negative 1, 1. So it's negative 1, 2, negative 1, 1. It's in row 2, column 1. Add those up. That's odd. So that's negative. C21 negative. That's okay. So now we're gonna go C22, which C22 should equal column 2, row 2. Cross those out. 1, 2, 0, 1. And that should be positive. 1, 2, 0, 1. And C23. So slowly you'll be able to recognize the patterns of the plus and minuses. So C23 is what? What is C23? C column 2 row 2, column 3, cross those out. We get 1, negative 1, 0, negative 1. 1, negative 1, 0, negative 1. So this is going to equal what? We have minus 1 plus 2 minus 1, so 1, so negative 1, right? And then 1, this is 1, C22 is 1, and negative 1, C23 is just negative 1, negative 1, right? Positive 1. Now, I just want to show you how this actually works. I'm not going to do the last, because I'm just going to kind of go over what do I do next. Well, C11, I'm going to make this matrix C12, C13, then we're going to do C21, C22, C23. I'm going to take the transpose of that, and that's going to give us our adjoint, which should be, we said, what was C11? 1, negative 3 here. We have another negative 3. C21 is negative 1. C22 is 1, 1, and a bunch of stuff here. Taking the transpose of that, what do? We just, this equals 1, negative 3, negative 3. Now it's going to be negative 1, 1, 1 here. Now, what this, we don't really need to worry about the side. What's closest to this is negative 1, 1, 1. That'll be D. So as we said in the first approximation, if you're really confident, you could have just gone with D right away. But yeah, that's number 15. Moving on to number 16. So number 16, we're working with eigenvalues of the matrix A, 2, 0, 0, 1, 2, negative 1, 1, 3, and negative 2. Before I start, I want to kind of define what an eigenvalue actually is. Eigenvalue is when the determinant, it makes the determinant equal 0. And this is it's studied in rotational motion, in computer graphics, vibrations, heat flows, and population dynamics. In upper years, you would be using these, and they're very important. So how do I actually find these eigenvalues? Well, this is called the eigenvalue. So what I want to do is I want to actually make this, bring this over here, minus ax equal to that 0, and factor out a x, and it's minus a. There's an identity here, so times x is going to equal 0, and the determinant of this matrix will actually equal 0. What this means is lambda times identity. That means lambda, 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 0, 0, 0, 0, 0, and 0, minus a. What is a? A is 2, 0, 0, 1, 2, negative 1, and it is 1, 3, negative 2. Right? So this is we have to make this times all this stuff times a vector we have no idea. It's x1, x2, x3, let's call it, equal to 0. So we can begin by literally just that's the determinant. We can begin by actually doing the subtraction. So that's lambda minus 2, 0, 0. This would be negative 1, lambda minus 2, right? Lambda minus 2, and we have 1 here. Then we have another negative 1, negative 3, and a lambda plus 2. And yeah, so now we want to find the determinant of what this actually is. Finding the determinant here, I'm going to use the old-fashioned method where it's just lambda minus 2, right, times, I'm going to try this right here, 1, negative 3, lambda plus 2. We're going to move on to the next part, which is going to be minus 0, who cares, and the next thing is also 0, so who cares, right? So this is all we have to worry about. They made it easier for us, I think. Okay, so this is, let's find the determinant here. This is pi minus 2, this is lambda minus 2, this is lambda minus 2, lambda plus 2, negative 3 subtract, so it's going to be plus 3, right? 80 minus BC, right? So let's just actually, lambda squared, I'm just factoring this out, so lambda squared plus 2 lambda minus lambda cancels out, minus 4, right? Because lambda squared plus lambda minus lambda, and then minus 4, and then we have plus 3, so this actually just turns into a negative 1. And this is also all times pi minus 2. So it's the lambda values are pi minus 2, pi plus 1, pi minus 1. So our lambda values are actually just pi equals, this eigen equals 2, eigen equals negative 1, and eigen equals 1. Our answer should be 2, negative 1, and then 1, which is 16a right there. And yeah, so this is eigenvectors. Basic concept behind it. What did I do? I set the determinant to equal 0. I took the determinant and I set it to equal 0. And now I'm finding the eigenvalues for that. This is an easier example than what you might expect. And yeah, so these are my 3 lambda values, eigenvalues that will actually make the determinant equals 0. Thanks.